The next step in our work with quadratics is solving quadratic equations. And when we talk about solving quadratic equations, what we really are talking about is finding the zeros or the roots or the x-intercepts of a quadratic equation. So if you think of a graph of a quadratic, we have a parabola, and remember the solutions to that quadratic equation are the x-intercepts. It's where the graph crosses the x-axis. And so at the x-axis, y is equal to 0. So to solve a quadratic equation, we'll need to set our equation equal to 0. Now, in today's notes, we're going to look at solving by factoring. So using the factored form of a quadratic equation to solve and get those zeros or those solutions. And so to solve by factoring, we set the equation equal to 0, factor completely the side of the equation that is not 0, and then we set each individual factor equal to 0 and solve, and then list our solutions. And the reason we set each factor equal to 0 is because if r, for example, let's look at example A here, 1a, if our equation is equal to 0, we have two things here, x plus 4 and x minus 5, and they're being multiplied together. So if our total equation product is 0, one or both of those factors has to equal 0. And so what we're doing is finding all the possible values of x that will make this product equal to 0. So for example 1 here, these equations are already factored. They're already written in factored form. All we have to do is set each factor equal to 0 and solve. So for example A, we have x plus 4 and x minus 5. So first we're going to set x plus 4 equal to 0, and then we'll set x minus 5 equal to 0, and solve both of these equations. Well, here we're just going to subtract 4, so x equals negative 4, and on this one we'll add 5, so x equals 5. So our solutions are negative 4 and 5. And these are the values that if you plugged in for x, you would get 0 for the equation. That's all there is to it. When it's already factored especially, pretty simple. Let's set each of these equal to 0, so y plus 1 and y minus 3 equal to 0. Now if you notice, all we're doing is the opposite operation, right? We'll subtract 1, so y equals negative 1. We'll add 3, so y equals 3. So when you don't have a coefficient on your variable, it's really just the opposite of the number you see in the problem. So y equals negative 1 and 3 here. Some of these you could probably do in your head, but I'm writing all the work out for the notes, so it's clear where we get these answers. Here we have 3d times 2d minus 5. So the factors of this equation are all the things being multiplied together. So 3d is a factor, and 2d minus 5 is a factor. So we're setting these equal to 0, 3d equals 0, and 2d minus 5. So here we'll divide by 3, we just get 0. And over here we have to add 5, two-step equation this time, and then divide by 2. So d equals 5 over 2. Now you could leave that as a fraction. Typically that's what I would recommend doing, so that way you don't have to worry about rounding or writing a repeating, if it's a repeating decimal. But this one is just 2.5, so either one of those numbers is totally fine to use. I just prefer to use the fraction. So our solutions are 0 and 5 over 2. Plus, if you just leave it as a fraction, you don't have to do any extra work. It already is 5 over 2, so you don't have to convert it to a decimal or anything like that. 2.5 is probably more useful for graphing. If you were trying to graph these solutions, 2.5 is maybe initially easier to figure out where it is on a graph than 5 over 2, but that's your choice. All right, now we're going to solve by factoring when they are not in factored form, so we have to figure this out. The first one says f of x equals 8x squared plus 2x. Well, first of all, we want to replace the f of x with 0, because we're trying to solve and figure out what the x values need to be when y, or the function, is equal to 0. And now here I can see that to factor this, I can take out a 2x, leaving 4x plus 1. And I believe that is all I can do. So now I need to set each factor equal to 0. So 2x equals 0, and 4x plus 1 equals 0. Well, the first one here, divide by 2, that just gives us 0. The second one, we'll subtract 1. So 4x equals negative 1. Then divide by 4. So x equals negative 1/4. So our solutions are 0 and negative 1/4. The more you do this, the more you can start to just be able to predict kind of what this is going to be. You know you have to subtract 1 and then divide by 4, so it's going to be negative 1/4. You can start to think ahead in these cases and maybe get the answers a little faster than writing all this workout. But if it helps you to write the workout, definitely do that. For this next one, we have to get all of our stuff, all of our terms, to one side or the other. So I'm going to go ahead and subtract 25 from both sides here. Doesn't really matter which side you put 0 on. So 4x squared minus 25 equals 0. And the reason I subtracted 25 is because I like to have a positive leading coefficient, because then I can easily factor a difference of squares if that's what it is. If I had negative 4x squared plus 25, I'd have to multiply by a negative 1 to get that difference of squares pattern. So now I can just take the square root of each term. So that's 2x and 5. And then I just have plus and minus in between. So for a difference of squares pattern, just take the square root of each term. And then plus and minus in between each one. And now we can solve by setting these equal to 0. So we have 2x plus 5 equals 0, and 2x minus 5 equals 0. You can probably predict these are going to be the same number, just opposite. So first we subtract 5 here, and we'll add 5 on this one. So 2x equals negative 5, and 2x equals positive 5. Divide by 2, and x equals negative 5 over 2 and positive 5 over 2. You may also see this type of thing written as plus and minus 5 over 2. That means the same thing. You can write them out separately or use that plus and minus symbol as long as it's the same number, just opposite. Okay, lastly, for example C, again, we want to replace y with 0. 4x squared plus 13x plus 3. We've got a trinomial here. So I want to find two numbers that multiply to 12 and add to 13. Well, that's going to be 1 and 12. So we're going to split that middle term. We've got 4x squared plus x plus 12x plus 3. Now we'll need to factor by grouping. So I can take an x out here, that's 4x plus 1. And I can take out a 3, and that's also 4x plus 1. So our factored form of our equation is 0 equals 4x plus 1 times x plus 3. Now that it's factored, we can set that equal to 0. Each factor here, 4x plus 1 equals 0, and x plus 3 equals 0, and solve. So subtract 1, divide by 4, and for this factor we get negative 1/4, and over here we'll just subtract 3, so x equals negative 3. So our solutions are negative 1/4 and negative 3. So factor each equation and then set each factor equal to 0 to find the solutions.